You've probably heard the hype about Yellowstone National Park, right? That it's sitting on a massive supervolcano, just waiting to blow and end civilization as we know it. Sounds like a blockbuster movie plot, doesn't it? Well, today we're going to bust some myths and dive deep, literally, into the real fascinating story of what's happening beneath Yellowstone's bubbling mud pots and spectacular geysers. The truth is way cooler, and a lot less scary than the headlines suggest. So let's start with the basics. What exactly is a supervolcano? It's not a specific type of volcano with a pointy cone. Instead, it refers to a volcanic eruption of an incredible magnitude, one that ejects over 1,000 cubic kilometers of material. To put that in perspective, that's enough to bury the entire state of Texas under several feet of ash. Yellowstone has had 3 such monster eruptions in its distant past. One 2.1 million years ago, another 1.3 million years ago, and the most recent one about 640,000 years ago. These events were truly cataclysmic and shaped the landscape we see today. The giant depression in the ground called a caldera, that forms the heart of the park. That's the scar left behind by that last massive eruption. But here it's the key point that often gets lost in the sensationalism. The volcano isn't a giant underground lake of molten rock just waiting to pop like a pimple. That's a huge misconception. The geology beneath Yellowstone is far more complex and, frankly, more interesting. Instead of a single massive chamber of liquid magma, what scientists have actually found is something more like a giant, hot, rocky sponge. Imagine a vast region deep beneath the park, stretching for miles. This area isn't hollow. It's filled with hot, solid, and semi-solid rock. Within this massive, heated rock body, there are small, scattered pockets of actual molten magma. Think of it like a sponge that's mostly solid but has water trapped in its pores. In this case, the sponge is hot rock, and the water is liquid magma. On average, the magma chamber is only about 5 to 15% molten. The rest is a crystal-rich, mushy solid. This distinction is crucial because a mostly solid, spongy system doesn't behave like a giant balloon ready to burst. It's much more stable. So where does all this heat come from? It originates from a mantle plume. Picture a gigantic superheated lava lamp rising from deep within the Earth's mantle, a layer far below the crust. This plume of hot rock has been stationed under the North American plate for millions of years. As the tectonic plate slowly drifts southwest over this stationary hotspot, the plume essentially acts like a blowtorch, melting the crust from below, and creating the series of volcanic calderas we can trace across Idaho's Snake River Plain, with Yellowstone being the most recent and active result. This intense heat is the engine that drives everything we see on the surface. All the famous geothermal features, Old Faithful, Grand Prismatic Spring, the bubbling mud pots, and the steaming fumaroles, are direct expressions of this deep heat source. Here's how it works. Rain and snow seep deep into the ground through cracks and fissures in the rock. As this water gets closer to the hot sponge of the magma chamber, it gets superheated, well above boiling point. But because of the immense pressure from the rock above it, the water stays in a liquid state. This superheated water is less dense than the colder water sinking down, so it begins to rise back toward the surface, dissolving minerals from the rock along its journey. This creates a massive, continuous plumbing system. When this hot water finds an open channel to the surface, you get a hot spring. The vibrant colors you see in places like Grand Prismatic are actually vast colonies of heat-loving microbes, with different colors representing different species that thrive at specific temperatures. Now, what about geysers like Old Faithful? A geyser is essentially a hot spring with a plumbing problem, a constriction or a kink in its underground channels. As the superheated water rises, the pressure starts to decrease. When it reaches a certain point, the top layer of water flashes into steam, expanding to over 2,500 times its original volume. This explosive expansion shoves the entire column of water above it out of the ground in a spectacular eruption. Once the pressure is released, the process starts all over again as the system refills with cool water, which then gets heated. The regularity of geysers like Old Faithful depends on the stability of this underground plumbing and the consistent heat supply. So the big question remains, is Yellowstone going to erupt again? The honest answer is yes, it almost certainly will. But, and this is a very important but, the chances of another cataclysmic, caldera-forming, super eruption are incredibly small. What's far more likely are smaller events. The most common form of volcanic activity at Yellowstone are lava flows. The last one happened about 70,000 years ago, and it was a slow-moving flow that oozed out and solidified within the caldera. This type of eruption, while significant locally, poses no threat to the continent or the world. Even more likely are hydrothermal explosions. These occur when the underground water flashes to steam with such force that it blasts a crater in the ground, hurling rock and hot water. These happen every few hundred or thousand years and are a localized hazard. But again, they are not the doomsday scenario people imagine. Scientists at the Yellowstone Volcano Observatory are constantly monitoring the park with an incredible array of instruments. They use seismometers to detect ground tremors, GPS stations to measure tiny changes in ground elevation. The ground actually breathes, rising and falling as magma and water shift below. And they analyze the chemistry of gases released from geothermal features. This network provides a continuous health checkup on the volcanic system. An impending eruption, especially a large one, would be preceded by dramatic warning signs. Intense earthquake swarms, rapid and significant ground deformation, and major changes in the geothermal system that would give weeks, months, or even years of warning. So the ticking time bomb narrative is really just a myth. Yellowstone isn't a bomb. It's a living, breathing geothermal system. The real story isn't one of impending doom, but of a powerful and beautiful natural process that has been shaping our planet for eons. The heat from below creates one of the most unique and dynamic ecosystems on Earth, a place where life thrives in extreme conditions. Understanding the rocky sponge model instead of the giant magma lake model helps us appreciate Yellowstone not as a threat, but as a window into the powerful forces that operate deep within our planet. Next time you see a video about Yellowstone's imminent eruption, remember what's really going on. The park is a testament to the planet's inner fire, a spectacular display of geology in action. It's a place to be respected, studied, and admired, not feared. Thanks so much for watching and for diving into the real science with me today. If you enjoyed this myth-busting journey, be sure to hit that like button and subscribe to the channel for more deep dives into the wonders of our world. Let me know in the comments what other scientific myths you'd like to see us tackle next. See you in the next video.